Let us take some question and answer in data structure using C. First is list out the areas in which data structures are applied extensively. They are applied, computer science everywhere, but compiler design they are specifically used: operating system, DBMS, statistical analysis package, numerical analysis, graphics, artificial intelligence simulation. What are the major data structure used in the following areas? RDBMS, this network data model and hierarchical data model. In network, the best would be graph because it easily emulates the structure. Hierarchical, it will be best will be tree, and RDBMS we'll see. The answer is RDBMS. The best is array of structures. RDBMS, array of structures, network data model, graph, hierarchical data model, trees. So if you are using C language to represent the heterogeneous linked list, what pointer type will you use? Of course, you are going to use what? Void. Because the heterogeneous linked list contains different types of data in its nodes and we need a link. So link pointer to connect them. It is not possible to use ordinary pointer for this. So we go for void pointer. Void pointer is capable of storing pointer of any type because void is a generic pointer type. Then minimum number of queues required for the priority queue. So there are two queues that are required. First is for actual storing of data. The other is for storing the priorities. What is the data structure used to perform recursion? Of course, stack. Why? Because stack, it uses LIFO, last in first of property. So it remembers the caller so that whom to return when the function has to return. So recursion makes use of the system stack for storing the return address of the function calls. And every recursive function has its equivalent iterative non-recursive function. So even when such equivalent iterative procedures are written, explicit stack can be used. What are the notations used in evaluation of arithmetic expression using prefix and postfix? Is it Polish and reverse Polish? The answer is Polish and reverse Polish. How many null nodes will a binary tree with 20 nodes have? Now you need to tell. Null nodes with a binary tree, 20 nodes. See. Let us take a tree with 5 nodes. Okay. So we have 1, 2, 3, 4, 5 nodes. These are null branches. So it will have only 6, that is 5 plus 1 null branches. Okay. 1, 2, 3, 4, 5, 6. So what 20? How many null nodes will binary tree have? If 20 nodes are there, so it will be n plus 1. That will be 20 plus 1. That will be 21. What are the methods available in storing sequential files? The methods are straight merging, natural merging, poly, phase sort, and distribution of initial runs. List out few applications of tree data structure. You can use tree for manipulation of arithmetic expression, symbol table construction, syntax analysis. List out few of the applications that make use of multi-link structures, sparse matrix, and index generation. In a tree construction, which is the suitable efficient data structure, so linked list will be the best. So linked list is the efficient data structure for tree construction. What type of algorithm is used in solving 8 queens problem? It is backtracking. The answer is backtracking. Now traverse the given tree using in order, pre-order, and post-order. See, these are the answers. In order. First, in order, what you have to do is, first these are in order, pre-order, and post-order. In order, what we do is, first we go to left, okay, left subtree or left node. Then we go to the node that is the root, and then we go to the right one. Okay, so this is root. So let us see in this what we are going to do. I'll do the in order for you and leave pre-order and post-order for you. In order is, first of all, we have to go to the left. So do A has some left? Yes, it has left. We have come to B. Do B has some left? Yes, it has left. So we go to D. Do D has some left subtree? No. So we'll take D first. Then, as we know that in this we have to go to the right one. So we have taken the root now. We have to go to the right, DH. So H will be there. Now we again come back and we see that here, because in this in order we have covered the left one. Now we have to take the root and then the right subtree. Now we have to take the root, that is B we have taken. Now do this have any right subtree? Yes, it has E. So we take E. Now the left subtree of this root is over. Now we can take this A. So we have taken A. Now we again go to the right subtree. We do the recursive again. As we come here to the this right subtree, we see that do this have any left subtree? Yes, it has. So we'll go to the left. Do this f has left or right? Left or right? First we check for the left. It has no left, right, no right. So we'll take f. Then we again go back, and now because left subtree is over, we'll take c because this is the root c. Now we go to the right. Okay, now right has again a subtree. So we go to the left. Do we have any left? To I and I? No left, no right. So we'll take I. Now we take the in order because we want to take the in order root. So we take G and finally J. So this is the in order. In the same way, the pre-order and post-order. Post-order you take root last, and in the pre-order you take root first. So this is the, I hope that you'll be able to do it. There are 8, 15, 13 and 14 nodes. These are nodes where they are in 4 different trees. Which of them could have formed a full binary tree? So we'll do it by rejection. The answer is 15. So in general there are 2n-1 nodes in a full binary tree. We know that there are 2n-1 in full binary tree. So by the method of elimination, full binary tree contain odd number of nodes. So there cannot be full binary for 8 and 14. We just remove them or does not consider them because they need to have odd number of nodes. 13 nodes you can form a complete binary tree, but it is not a full binary tree. So the answer will be 15. In a given binary tree, use array. Using array, you can store the node 4 at which location. So this is your given binary tree 1, 2, 3, 4, 5. Using an array, you can store the node 4 at which location? Let us see. The answer is at location 6. How? See, we have to store the 4th location. So let us see how this is done. So let us see how we are going to store it first of all. Then I'll tell you how we have gone to this location 6. First we'll take the root. We store it here. Then we see what is the left child of C. Left child of this 1. Left child is 2, so we place it here. This is the left child. This is the root. Now we see what is the right child. This is 3, so we write the right child. When this is over, we go to the this left subchild of 1, that is 2. What is the left subchild? That is the leaf. There is no left subchild, so we place nothing. So left subchild of 2 is nothing, so we place nothing here, null here. What is the right because this is a binary tree, we have to keep all these values because sometime it will come. What is the right subchild of 2? It is nothing, so we keep null here. Now we come to this node, right subchild of 1. What is the left subchild? Because 3 has already been stored here. What is the left subchild of 4? This is 4, so we see the right subchild. And then we see that there is nothing here, so we keep the null here. Then we go to the next one, that is the 5th, that is the left subchild of 4, that is null, so we keep here. Then we go to the 5 and we place 5 here. So this is at the location of 6, right? Sort the given values using quick sort. These are the values you have to use the quick sort. So let me tell you how we are going to do this quick sort. Sorting takes place from the pivot value. These are the values. We have to start from the pivot value, which is the first value of the given elements. Okay. Now the first value of the given elements. So let me tell you that the first value, this is the pivot value. Okay. Now after first go or after first iteration, 65 will find its position in the which is at the correct position. So with sorting will take place from the pivot value, and which is the first value of the given element, which is 65 here. And the value at the left pointer and right pointer, these are indicated by L and R. So this will be L and this will be R. Okay. Now we need to see what is going on. We will compare for this left with R. What is happening? This will be exchange. So, 45 is lower than 70. So 45 will come here, 70 will go here. And left will come to the next position, right will come to the next position. Now we have left this, right this. Which is lower, 50 is lower. So again an exchange will be done. 50 comes here, 75 comes here, left and right changes its, means it is incremented, it is decremented. 80 and 55, which is smaller, 55 is smaller, so we have to exchange. 55 comes here, 80 goes here, 80 comes here. Now L and R, L will increase, R will decrease. Now 85 and 60, what will happen? Again an exchange will happen. So 60 and 85. So now this L and R pointers cross each other. the pivot value is interchanged with the value at the right pointer. Okay, so if the pivot value is changed, it means that the pivot has actually occupied its original position in the sorted order. So hence we have two different arrays which are formed. And how this is formed, let's just remember this. I'm going to the next phase. So once start from the original to the pivot value and then pivot value to the end. How? See, this 65 has taken its correct position from where we have started. This was the correct 65 we have started, and now this 65 is in the correct position now. Now again we get two different arrays. This is the first array, this is the other array, and we do it again for this same stuff. Left is compared with R, which is smaller, 55 is smaller than 60, 55 is exchange. Left and R will change its place. Now we see how to deal with these two. These two, 50 and 55, 50 is smaller, so 50 will change its place, 50, and 55 will come here. Now left remains the same, R is 45. Okay. Now you want to change it, you can again change it, 45 and 50. So you'll get 45, 50 here, 55 here, and 60 here. 65 was in the correct position. What about 70, 80, 75, 85? First this will check. 85, 70, 70 is smaller, we'll change it. 70 will come here, and 85 will go here. Okay. Now right will remain here, right has come here, left will go this place. Let us see left and right. What is the correct sequence? We see that 75 and 80, there is nothing going on here, but here we have to increase the R to this point, R and L. 75 and 80, this will change the position. 75 will come here, 80 will get his position, and now this is the sorted array by the quick sort. For a given graph, draw the DFS and BFS. That is, DFS is depth first search, BFS is the breadth first search. So the answer would be just consider that these are the value in from A to C. We have final value A, B, C, D, E, F, G, H, I. So you can mark it and just apply BFS and DFS. So this is the answer. Classify the hashing function on the various method by which the key value is found. You can have various hashing function. It can be direct method, it can be subtraction method, modular division method, digit extraction method, mid square method, folding method, pseudo random method. These are all the methods you can apply for hashing function. These are. The next is what are the types of collision resolution technique and the methods used in each of the type. Collision resolution technique. So these are the collision resolution technique. Open addressing. The method used in this is overflow block. Close addressing, that is open hoshing. We use linked list and binary here. In RDBMS, what is the efficient data structure used in internal storage representation? B plus tree. Because B plus tree, all the data are stored only in the leaf node. There is no data stored in the intermediate tree nodes. Only in the leaf node the data is stored. So it makes the searching quite easier. So this corresponds to the records that shall be stored in the leaf nodes. Next is draw the B tree of order 3, creating this B tree created by inserting the following data arriving in sequence. So please try it, how you can draw the B tree. And this is the B tree actually. We'll start with the, you have to first start with, in B tree the important aspect is, all the members here will be less than 11 and all the members here will be greater than 11. And there is always, there is always some breaking is going on. So this is the actual version. We have a B tree with this sequence. Okay. So I hope you will do it by yourself. This is the answer. What is a spanning tree? A spanning tree is a tree associated with the network. So all the nodes of the graph appear in the tree once. A minimum spanning tree is a spanning tree organized so that the total edge weight between the nodes is minimized. Now, does the MST, a minimum spanning tree of a graph, give the shortest distance between any two specified nodes? The answer is no. Minimum spanning tree assures that the total weight of the tree is kept at its minimum. But it will not guarantee, it doesn't mean that the distance between any two nodes involved in the minimum spanning tree is minimum. This is the graph. Convert the graph into weighted edges to MST. I hope you'll be doing it. I'll tell you the answer just now. This is the correct answer, the equivalent minimum spanning tree. So we start from here, okay, or you can start from here also. Any point you can take. So we start from 2, go to 4, 10, which is the lowest, 600, 612, so 2958. we take 612 to 4, then we take 310, and then we go to 300. If you add all these three, any other path you choose, this number will always be less than that. This is the minimum spanning tree. Whether linked list is a linear or non-linear data structure. See, if you talk about the access strategy, it is linear, and storage strategy, it is non-linear. So, according to the access strategy, linked list is linear. According to the storage, linked list is non-linear. Draw the binary tree of this expression. Okay, this is A into B, then minus into is also here, P divided by Q. Okay, then P divided by Q is here, C into D is here, that is plus, and then this is multiplied, these two are multiplied, and finally A plus B minus of this. This is the binary tree for this expression. For the following COBOL code, draw the binary tree. This is the COBOL tree. So I hope you'll be able to draw it. I'll tell you the answer. This is the binary tree. Student REC 1, 2 is the name, first name, last name, year of study, first semester, second semester. What is the difference between a queue and a stack? Queue and a stack. A queue is FIFO, first in, first out. Priority queues doesn't quite follow that, but while a stack is LIFO. Elements get inserted at one end of the queue and retrieved from the another, or deleted from the another, while the insertion and removal operation for the stack are done at the same end. So what is the difference between storing data on the heap versus on the stack? A stack is smaller but quicker for creating variables. These are the auto variables. Heap is limited in the size only by how much memory that can be allocated. So if you want to create or find the memory for the malloc and calloc and new malloc and new functions, so dynamically created memory will be taken from heap. Stack would include most compile time variables, while heap would include anything created with the malloc or new. This is for C++. Let W be the string ABCD. Find the length of W. List all substrings of W. Now, can you answer this? Length is 4, of course. ABCD. So there are 4 characters. So length of ABCD is W 4. Substrings is first of all ABCD, then ABC, BCD, AB, BC, CD, A, B, C, D individually, and a null string. Write the syntax of node creation. How to create a node, and this is done by you write a structure. You create a structure. You can name it as node, and inside it you have 2 items. First is your data type. This can be any data type like int x, and then you have a pointer of type structure node only. This node, this structure, the pointer will be type of this pointer for link node, and then you can name the structure, say temp. This is the structure variable. Write the syntax for pointing to next node. So how you are going to do this? Node link is equal to node. This can be the syntax for pointing to the next node. It is what you are going to do here is, in this case, you can just write that ptr, say next. Okay, like node next or node link is equal to node 1. This is the first node. So what we are trying to do is we are pointing to the next node. So if ptr is this, pointer is this, so the data item would be ptr data, and the item would be ptr next, or whatever you give like this. Ptr next will be some node. What is sorting? Sorting is the process of arranging elements in some logical order, and specifically in increasing ascending order as a default. Sorting is also descending, but it is not default. By default, we talk about ascending order only. So sorting methods are classified into 2 categories: external sorting and internal sorting. What is external sorting? External sorting, this deals with sorting of data stored in external files. So this method is used when the volume of data is quite large and cannot be held in computer's RAM. While the internal sorting, this deals with the sorting which is of the data which is held in the RAM of the computer. list some popular sorting method. Bubble sort. Let me first talk about or indicate the most popular. Then we'll go to others. First is our merge sort. Then comes the quick sort. Then comes the insertion sort. Then selection sort, bucket sort, cell sort, and bubble sort. Explain the bubble sort. This is the bubble sort, and this is all theory or the steps. You must read it, but I'll tell you how it is done. I'll tell you one phase. See, if your number are like this 23, 21, 42, 61, 3, 8, 20, let be like this. Okay. So what is done here is, first we'll start from any point. You can start from here, you can start from here. Actually, bubble sort means you are bubbling up. In the water, bubble goes up. So at one iteration, the highest member will be on the top. So what we do here is, we compare 3 to 61. Which is the greater one? 61. So 61 and 3 will not be swapped or exchanged. Let us see 42 and 61. So 42 and 61. 61 is greater than 42. So now 61 and 42 will be swapped. So 61 will come here and 42 will come here. Now these two will be compared. 61 and 21. 61 is again greater than 21, so need to be swapped. 61 will come here and 21 will come here. Now 61 will be compared with 23. So 61 is greater than 23. This will be swapped. So 61 will come here and 23 will come here. So after one pass, this will be 63, 23, 21, 42, and then 3. So for one pass, the highest element, the maximum of all will come this side on the top, and then or you can do it in this way, that you can compare. If this is less, then you shift, otherwise not. So it depends on you how you implement bubble sort. But this is one iteration. So this now the iteration will leave the 63, and now the iteration will go here. 23 will be compared with 21 and like this. This is the bubble sort. It requires n-1 passes to sort an array. So in each pass, every AI is compared with the next one, and which k is the pass number. If AI is greater than a plus 1, then they are swapped, the way I said. Now this will cause the largest element or to move up or bubble up, as 63 has bubbled up. And then after the end of the first pass, this was just the first pass. This will be leaved. 63 will not be taken into account. For the next numbers, the same will go on. So this is the swapping process. Please read them, pause and read and understand it very carefully. What is the complexity of bubble sort? Complexity of bubble sort is n square. Even in the best case, even in the worst case. How it is given? First pass required, because there are two for loops. We have to apply two for loops. Say 1 to n-1. So first pass require the n-1 comparison, because as we see that 1 to n elements are there. So the comparison will be, how many comparison? That will be n-1 comparison. Now one element, first element will come here. So we'll be left with only n-2 element. So comparison will be n-2 plus n-2. Then other element or the next top will come, next highest will come here. So 2 will be done. So we'll left with n-3. And likewise, till the time only one element is left. So it will be n-1 till 1. Let us add them. So the kth pass will require n-k. This is n-k comparison. The last pass requires only one comparison, like this. So we add it. We know this is this normal sum, 1 plus 2 plus 3 till n-1. This is n-1 by 2, and this is nothing but the order of n. This can be written as n square minus 1 by 2, or n square by 2 minus 1 by 2, and we leave all this constant term, we take order of n square. What is insertion sort? Insertion sort is like playing card. You have one card in your hand, you pick from the pile of card another card, you place it in the right position. Now these two are sorted. You again pick a card and you find the correct position, maybe in between or before it or after it. So now these three are sorted. This is the insertion sort. So this is very popular with the bridge players when they sort their cards, and the insertion sort has come from that only. In this procedure, we pick a particular value and then insert it in the appropriate place in the sorted sublist. So procedure for insertion sort, we require n-1 passes. So first of all, A1 is inserted either before or after A0, so that A0 and A1 are sorted. Okay, so if these are element, this is A0. So A1 will be these two will be compared. So A1 will either come before A0 or will remain here. So this will be sorted. Then comes the A2. A2 is either inserted before A0, in between A0 and A1, or will be here only. So these three will be sorted. Now A3 will come again because this is sorted, so it will find its position and this will go on. This is how the insertion sort takes place. So let us see with an example. 20. These are the numbers 20 to 50. We use insertion sort here. So this is the array 20, 35, 40, 100, 3, 10, 50. So pass 1 will be A0 will be will place them in an array. So A0 will be 20, A1 will be 35, A2 will be 40, A3 will be 100, A4 will be 3, A5 will be 10, and A6 will be 15. What pass 1 will give? Because A1 is less than A0. So in the ascending order, 20 should come before 35. So in the first pass, what will happen? We insert element A1 before A0. A1 before A0, because we know that we want the last, we want the minimum number to come here, minimum, and maximum number to be here. Okay, so what will happen here? The values 20, this two will be compared, and because A1, this A35 is less than A0, 35 will come here or 20 will come here. Then we go to the pass 2. We see A2. A2 is greater than 35. So we'll take no action. No action will be taken. Now we come to the next pass. A3. A3 will be compared to A2. What will happen? A3 is greater than A2. So no comparison, no action will be taken. So 40 will be here, 100 will be here. Now we see in this case, the next pass. A4 is less than A3 and it is less than A2 also, it is less than A1 also, it is less than A0 also. So all these needs to be shifted. So A4 will come at 0 position and all this will be shifted. 20, 35, 40, 100 will be shifted. Right? I hope you understand. So 100, 10 and 15. This will be there. Only this 3 has gone here. Otherwise, all these are shifted to the right. Right. Now, we check for A5. A5 or say A5. Now, A5 is less than A4, A3, A2, A1. So again, the same sequence will be done. Means A5 will be shifted to A1 and these all will be shifted to the right. So all these are shifted to the right. A10 will find its place here. 3 was here, 10 was here. All these are shifted. Now we compare A6. A6 is compared to 100, compared to 40, compared to 35, compared to 10, 20. So till this point, these are A6 is less than all these, A2 to A5. But A6 is greater than A1. So what we'll do, we will insert this element here and we'll shift all these on the right. So this all will be shifted on the right. This is 3, 10, 15, 20, 35, 40, 100. This is how insertion sort is done. What is the complexity of insertion sort? Order of n square is the complexity of insertion sort, because in the worst case performance occurs when the elements in the input are in descending order. So in this worst case, the first pass will require one comparison. The pass will require the second pass will require 2 comparison, and the last pass will require say n-1 comparison. So in general, kth pass will have n-k comparison. So total number of comparison will be 1 plus 2 plus till n-1, and that will be n-1 by 2, and we know that it is at order of n square. What is bucket sort? See, most people use the bucket sort method when sorting a list of name of alphabetical order. We are talking about the strings here, alphabetical order. So what the procedure is, first these names are grouped according to the first letter. So we have around 26 classes. So one for each element of the alphabet. So first class consists of those names that begin with letter A. And the second consists of those begins with letter B and so on. So first bucket will be all A. Second will be B and so on. Next, the names are grouped according to the second letter. First letter is done, second letter. So after this step, the list of name will be sorted with respect to first two letters. So this process is continued. First letter, second letter, third letter, and so on. So this process is continued for a number of times equal to the length of the name with the maximum letters. So if say letter some string may have letter 3 letters, some string may have 10 letters also. So this will go on for 10 times. And since these there are 26 letters in the alphabet, we make use of 26 bucket, one for each letter of the alphabet. So after grouping of these names according to their specific letter, we collect them according to the order of the bucket. So this new list becomes the input for the next pass when we consider the next letter, this letter. So after all these passes, these values of these strings will be in the sorted order. Write the algorithm for bucket sort. So this is bucket, where A is the linear array of integer with n elements, and the variable digit count is also there to store the number of digits in the largest number in order to control the number of passes, because we need to know what is the length of the string, maximum length string. So we start with the begin and end, and we find the largest number of the array first, and we set the digit count to the number of digits of the largest number, this one. And for pass 1 to digit count, which we have already computed, what we do, we initialize the buckets from A to Z, that is 26, and from I equal to 1 to n minus 1, this n, we set digit, we obtain digit number for pass AI and put AI into the bucket number, and we increment bucket count for bucket number digit. Then we collect all the numbers from the bucket in order. This is the bucket sort. What is the complexity of bucket sort? Complexity, see, suppose the number of digits in the largest number of a given array is s. The string is of length, say s, highest number. The number of pass to be performed is n. Then the total number of comparison needed to sort a given array is equal to n into s into 10. Why this 10 is? 10 is the decimal base number. So n is the number of comparison, and s is the number of digit in the largest number of a given array. So this will be fn equal to n into s into 10, where s is independent of 10. But if s equal to n, somehow the worst case will happen. So it will be order of n square. But since s is equal to log of base 10n, if sometimes it happens, then the function will go down to n log n, but the base will be 10. So we conclude that the bucket sort performs well only when the number of digits in the elements are very small. That does not happen always. What is merge sort? Merge sort is a very good algorithm of sorting. In this algorithm, what we do, if we do it recursively, we call merge sort twice. One for the, if these are element, one from this part to this part, the other from this part to this part. So merge sort will be called twice recursively, merge sort calling. Then we merge the element. So merging is very important. So merging means combining elements of two arrays to form a new array. So the simplest way of merging two arrays is to first copy all elements in one array into a new array, and then append all the elements of the second array to the new array. So if you want the resultant array to be sorted, you can sort it by any of the sorting techniques. So if the arrays are originally in the sorted order, they can be merged in such a way as to ensure that the combined array is always sorted. This is known as the merge sort. Let us see the procedure of merge sort. The technique of merge sort is, or sorting during merging, is much more efficient than sorting after merging for arrays that are already sorted. So let us consider two arrays, say A7 and B5, to be merged to form a new array. The new array will have, say, 7 plus 5, that is 12 elements. So we compare A0 with B0, A0 with B0. If A0 is less than B0, we move A0 to C0. We increment the pointers of array A and array C. The pointer that array is incremented whose element is moved in the third array. So this is A, this is B, and this is C. So we compare these two elements, and after comparing, we just transfer this to C. Now we compare A and B, where the pointers are pointing. The pointer will increment likewise. So we compare A1 with now B0. Suppose B0 is less than A1. We now move B0 to C1. C0 has already been taken by A0. So we move B0 to C1 and then increment B's pointer now to point to the next element of B1. So this is how it is done. What is quicksort algorithm? Quicksort is like merge sort. It is also a divide and conquer sorting algorithm. To understand quicksort, let us look at the high level description of the algorithm. First we divide, we recurse, and then we conquer. So in this we partition. Basically quicksort means partition. So partitioning is the main main criteria. So whenever we partition, we always place a value such that the left hand side partition is always sorted. Okay. So if the sequence has two elements, select an element x from S to be your pivot. So we take pivot as this element, last one. Any arbitrary element like the last will do. So we always take this pivot as the last one. Remove all elements of S and divide them into three sequences. That is L, which hold the element which are less than x, E, which holds the S element equal to x, and then G, this part, which holds the element greater than x. And we recursively sort L and G, these two parts. And finally, we put elements back into S in order, and we first insert the element of L, and then the E, and then this of the G. What is the complexity of quicksort algorithm? See, quicksort is also partitioning. So if the partitioning is exactly n by 2, so the complexity will be like merge sort only, order of n log n. But finding the location of the element that splits the array into section is of order n operation, because every element in the array is compared to the pivot element, this element. So after the division, each section is examined separately. So the array is split approximately half, which is an optimistic assumption, of course. There will be log n splits. So total comparison will be order of n log n. Otherwise, if it is not half, then it will be order of n square, the complexity of quicksort. What is selection sort? Selection sort requires n minus 1 passes to sort an array. So in the first pass, we find the smallest element in these and swap it with the first element, that is A0. In the second pass, we find again the smallest element and we swap it with the A1, and so on. What is the process of selection sort then? As we said, we have different passes. Let us see the first pass. We find the location of the smallest element in the entire array, this array. We interchange, say we found it in certain A location. So we interchange A location with A0 because A location, this at our smallest element is found at A location, A position this. Because A0 is always, one element is already sorted. So we exchange this. Then we find the location of the smallest element in the entire array again. Because A0 is already done, we don't take A0 here. So A0 is not here. A1, we start with A1 and AN minus 1. We can find the smallest one and we replaced it with the A1 in a location, and we do it likewise. So these are the elements. Let us see how we can apply this sorting algorithm on this. So let us see. We have these elements, and we've already done this question. You know how we did this, but we'll apply it, or we'll apply the selection sort here. Okay. So let us see. This is the first pass. So the pass, this is, let us put these values into an array. So we have an array of 20, 35, 40, 100, 3, 10, 15, the elements which are given here. The pass one will say, we have to find the minimum value. Which is the minimum value here? This is the minimum value. And what is the location? A4. So location is 4. This is the location, 4. LOC is 4. So we exchange A4 with A0. So 3 will come here, 20 will come here. This is now done. So we find the lowest value in these. Okay. So what is the lowest value? We have already interchanged A0 and A4. Now this is the pass 2. Let us see which is the lowest. Which is the lowest? Lowest is now 10 in this pass. So we'll exchange 10 with 35. So 35 will come here. 35 will come here and 10 will go here. So these two are done. Now let us concentrate on these 5 values. Which is the lowest? 20 is the lowest. So location is 15 is the lowest. Location is 6. So we exchange 15 with the 40. Means A2 and A6 will be exchanged. So 15 will come here and 40 will go this side. This will be 40. This will be 40, I guess. This will be 40. Okay. Now these 3 are already done. We are left with 4 elements. So let us see which is the lowest. 15 is the lowest. So this is 40. Sorry, 40 is the lowest. 40 is here, but the lowest in this element are 20. So 20 will retain its position. No interchanging will be done. We are left with 135 and 40. Which is the lowest? 35. So we exchange these two. 35 will come here, 100 will go there. Now we are left with only these two. What is the location of the lowest one? A6. So we exchange A6 with the A5. So finally, using the sort, the sorting is done like this. What is the complexity of insertion sort? We have already seen that it is order of n square. The first part would require n minus 1, second pass n minus 2. Any kth pass will have n minus k comparison, so it will be n minus 1 by 2. Write a sum algorithm to find the smallest element in the array. So what we'll do here is, if we want to find the smallest element, A is a linear size, A is array of size n. So the sum algorithm finds the location of smallest element among these a1 to n minus 1. So what we are going to do is, we'll assign the first or any element like the k minus 1th element to the smallest. Then we compare each with the other one. See, if this is an array, what will we do here? We'll take this as the smallest, and then we compare this with each element. And once we found any element less than this, we will assign smallest, or we'll assign this element to the smallest, and we again this is done. We'll compare this with every element and smallest, and then we again reiterate it. We begin like this. So we take a small element until location k minus 1 for the loop. We do till k to n minus 1, and we compare. If we get an element which is less than smallest, we assign the small to the next element and the location as j. And write selection sort algorithm. We have already done this, but let us see selection sort algorithm. Here A is the element, selection sort A is the linear array with n elements. So this algorithm sorts element into ascending order. So it uses a temporary variable temp to facilitate the exchange of two values, and variable I to use as a loop control variable. So we start from I to n minus 1. We call the smallest element. We find the smallest element, and then we exchange temp with I minus 1, and we set I minus 1 is equal to a location, and we set temp equal to a location, and this we end. Okay. How do you create an empty linked list? This is how we create an empty linked list. This variable is used to point to the first element of the list. Since the list will be empty in the beginning, the variable head will have is assigned to a sentinel value to indicate that the list is empty. So we create an empty list with node pointer of head. That head will have a null value. Let us take a few more. Name some operation on linked lists. So linked list, there are various operations what you can do. You can add an element, you can delete an element, you can traverse the linked list. So all these operations can be performed. So the main operation that can be performed on a linked list are traversing and searching. And of course, the traversing and searching is done linearly in a linear linked list. Then inserting of an element in a linked list and deleting an element in a linked list. These are some operations on linked list. What is a heap? What do we mean by heap? See, there are two different things. The memory heap is different from what heaped binary tree is. In memory, we see that we have stack memory and then heap memory. Heap memory is the open free space which is created by malloc and of course new. But this heap is somewhat different. This is a binary tree. Or heap is a heap when a binary tree is called a heap when it follows certain property. What the property is, either it should be empty, a binary tree be empty, or in a heap, the root is the larger than either the child or both subtree. Means the heap can be used. First, let me tell you what exactly heap is. This is the highest element or the lowest element. You can also, there are two properties, heap, mini heap and max heap. So if we consider this to be the highest element, all other element, like if this is another root or another root for this subtree, but a child for this tree or this root. So this is left subchild, this is right subchild. So what this heap is, it is following the heap property that the element here is greater than all the elements in the left or right subtree. And in the similar fashion, this element is greater than all the elements which are here. In the similar fashion, this element is greater than all the elements here. So the binary tree is a heap if it is empty, of course. And the key in the root, this root is either larger than either the child or both left or right subtree that have the again heap property. So this also has a heap property. So a heap can be used to make a priority queue. The highest priority item is at the root and is trivially extracted. But if root is deleted, what we are going to do? We are left with two subtrees. So we must efficiently recreate a single tree with a heap property. So what we do here, we generally, when we delete, so the rightmost or the lowest element or the rightmost, that is transferred to the root, and it is allowed to flow down to the proper position. The value of the heap structure is that we can extract the highest priority item, and this is the highest one, or if it is a mini heap, then minimum or the lowest number can be extracted. So it takes only order of log n time to insert a new one. So you can easily get a value and easily insert also a new value. So this is a heap. Define AVL tree. AVL tree, the name has come from AVL, that is those gentlemen who have created it, or who have devised it. AVL tree is again a binary search tree. See, this is a binary tree. Heap is a binary tree, but AVL is a binary search tree. It is a binary search tree. So it has the properties like the subtree of every node differ in height by at most one, that is -1, 0, or 1, and every subtree should be an AVL tree, right? Then what is the Dijkstra's algorithm? Dijkstra's algorithm. So Dijkstra's algorithm. So Dijkstra's algorithm, which is named after its discoverer, the great E.W. Dijkstra, solves the problem of finding the shortest path from point in a graph, that is the source to the destination. So from source to destination, if you need to find out the shortest path, Dijkstra algorithm is going to help you. So it turns out that one can find the shortest path from a given source to all points in a graph at the same time. Hence this problem is sometimes called as the single source shortest path problem. Give mode of operations in Dijkstra's algorithm. Dijkstra's algorithm keeps two set of vertices, S and V minus S. S is the set of vertices whose shortest path from the source have already been determined, and V minus S is these are the remaining vertices. There are other data structures also which are needed here. D, that is the array of best estimate of the shortest path to each vertex, and Pi, an array of predecessor of each vertex. So the basic mode of operation is like this: we initialize this D, we initialize this Pi, and we set S to empty. And while there are still vertices in V minus S, we sort the vertices in V minus S according to the current best estimate of their distance from the source. We add U, the closest vertex in V minus S, to S, and we relax all the vertices till repeat all the vertices till V minus S is connected to U. Explain the greedy algorithm. What is the greedy algorithm? Greedy means whatever is there presently, a greedy person will take it, will take there itself. So many algorithms can be formulated as a finite set series of guesses. Example, in the traveling salesman problem, we try to guess each possible tour in turn and determine its cost. So when we have tried them all, we know that there is one, which one is the optimum or least one. However, we must try them all before we can be certain that we know what is the optimum one. So it leads to the order of factorial n algorithm. So intuitive strategies such as building up the salesman tool by adding the city which is the closest to the current city can readily be shown to produce suboptimal tools. Not optimal, but suboptimal tools. So as another example, an experienced chess player will not take an opponent's pawn with his queen, because that move would will produce the maximal gain, the capture of a piece, if his opponent is guarding that pawn with another pawn. So in such games, you must look at all the moves ahead to ensure that one you choose is in fact the optimal one. So all chess players know that short-sighted strategies are good recipes for disaster. So there is a class of algorithms, the greedy algorithm, in which we can find a solution by using only knowledge available at that time. The next choice must be made, or guess must be made. So the problem of finding the maximum or minimum spanning tree, sorry, not maximum, but minimum spanning tree, is a good example of this class. This is greedy algorithm. What are partitions? What do we mean by partitions? A partition is a set of or sets of element of a set, where every element of the set belongs to one of the sets in the partition, and no element of the set belongs to more than one of the subsets. Partition, you can just assume it to be subdivision, because we generally say in various sort also we use partition, various data structures also, algorithms also, we use this partition. What are spanning trees? Spanning tree of a graph G is a set of v minus 1 edges that connect all vertices of the graph. So all vertices connected without repeating them. So a spanning tree is formed by the graph G. What is MST then? Minimum spanning tree. If a cost say Cij is associated with each edge Eij, this cost is with each edge Eij, which is from vertex 1 to vertex I to vertex j, then the minimum spanning tree is the set of all edges, which is E span, forming a spanning tree such that C, the sum of Cij to all Eij in E span, is always minimum. What does Kruskal algorithm do? Kruskal. This algorithm creates a forest of trees. Kruskal creates forest of trees. So initially the forest consists of n single node trees, that is no edges, n single node trees. So at each step we add one, that is the cheapest one edge, so that it joins two trees together. So if it were to form a cycle, it would simply link two nodes that were already part of single connected tree, so that things or this edge would not be needed. So let us see the steps to construct a forest. First, to construct a forest with each node in a separate tree, place the edges in a priority queue, and until we have added n-1 edges, continue extracting the cheapest edge from the queue until we find one that does not form the cycle. We add it to the forest, and adding it to the forest will join two trees together, and every step joins two trees in the forest together, so that at the end only one tree will remain empty. Explain the circularly linked list. Circular linked list is like this. If you have a linked list, the last one is not pointing to the null. The last node will not point, the pointer of last node will not point to the null, but it will point to the first one. So by ensuring that the tail of the list is always pointing to the head, we can build a circularly linked list. So if the external pointer that, for example, if implemented using struct t node, in this case, in our implementation, points to the current tail of the list, then the head is found trivially by tail next, permitting us to have either LIFO or a FIFO list with only one external pointer. So in modern processors, because the few bytes of memory saved this way would probably not be regarded as significant. Circularly linked list would more likely to be used in an application which required a round-robin scheduling or processing. What are doubly linked lists? Doubly linked lists are like this. They have a pointer. They have a pointer to the preceding. This is the preceding item, as well as to the next item. So this node will have item previous address also, next address also. What is binary tree? The simplest form of binary tree is binary tree. A binary tree consists of a node called the root node, and you have left subtree and right subtree, and both the subtrees are themselves binary tree, but there is a main implication here is, or restriction here is, any node can have maximum of 2 nodes. Because this is binary. Bi means 2. What are complete trees? These are complete trees. A complete tree, this forms a complete tree whose height is defined as the number of links from the root to the deepest leaf. Okay, this is the complete tree. All the nodes are complete. This is a complete tree. What is an M-way search tree? An M-way search tree. First of all, M-way search tree, the definition would be like this: it is empty, or it consists of a root containing j, that is j belongs to 1 to m, because M-way search, j belongs to 1 to m keys, the kj, and each subtree ti such that k, which is k is a tree in t0, where k is less than or equal to k1. If k is a key in ti, where I belongs to between 0 to j, and k belongs to ki and k plus 1 or I plus 1, and if k is a key in tj, then k is greater than kj. So all ti are non-empty M-way search tree, or all bi are empty. So what it is saying is, you have a node, okay, it can have these number of keys which we are talking about. So it can point to another node which can have this number of t, it can point to another node which can have another number of trees, so the maximum could be m. This is M-way search tree. What is quicksort algorithm? We have already seen this, but we'll see another discussion or another definition of this. Quicksort is a very efficient sorting algorithm because At one point, it can give you order of L log n, that is equivalent to merge sort. So quicksort is very efficient searching algorithm invented by CAR Hoare, H-O-A-R-E. So it has two phase, partitioning phase and the sort phase. So these two phases, you can do it iteratively or recursively. Most of the work is done in the partition phase only. This is the main or you can say the heart of the quicksort algorithm. So it works out where to divide the work. The sort phase simply sorts the two smaller problems that are generated in the partition phase. This makes quicksort a good example of divide and conquer strategy for solving problems. So we have already seen an example on this approach in the binary search procedure. We have already done this. So in quicksort, we divide the array of the item to be sorted in two partitions and then call the quicksort procedure recursively to sort the two partitions. That is, we divide the problem into two smaller ones and then try to conquer by solving the small ones. Program to allocate memory dynamically for strings and store their addresses in array of pointers to strings. Can you make a program like this? So this is the program to allocate memory dynamically for strings and store their addresses in array of pointers to string. Array of pointers. So these are the including file. We have a character, say name, character string, int I. This is clear screen. This is a for loop. We want to accept the string from the user. So we do a print up, enter a string on the console, then we say get s. So string will be received from the user. And now we are allocating it. Malloc string length, because str is this, so str plus 1. We have to take the string length of string so that we know what is the length of the string, and then we add 1. And then we do malloc. We know that malloc returns void, so we have to cast it like character star, and we assign it to name I, which we have given here. Okay. Then we string copy this str to name I. Then we print the strings are. And how we are going to print? This is done 5 times. See, this loop goes for 5 times. So when this is are done, this we can print it. How you are going to print it? Again a for loop for name I. Okay, and then we free the name what we have got. So 0 to 5 we free it. So this is how we allocate memory dynamically for strings and store the addresses in array of pointers to string. So this is all about the C, or using C we have seen the data structure. Thank you so much.